I'm very pleased to welcome you to panel 6A, which is focusing on planetary consensus for addressing the challenges of climate change. So the main question here is, how are we doing with regards to hedging against aggravating climate change and the extreme weather events that are connected with it? What is the forecast with regards to what can be achieved, and how we can increase the probability of being able to manage this crisis within this framework of multi-crisis that does not just concern climate change, but also biodiversity collapse, and does not just concern environmental crisis, but also inequality crisis, increasing inequalities between the global north and the global south, and increasing difficulties with economic growth, lower economic growth that we need, shrinking fiscal spaces, even in the developed world, and issues with the skills that are needed and their real existence in the labor market. So it's a multi-crisis. One of these crises is climate change. And I would like to share my screen. And in this panel, we are going to focus on this climate change crisis. So in my presentation, which is just an introduction to the panel, for me, the crucial question is whether we are able to meet what we have committed to during the climate agreement. Climate agreement 2015, 197 countries agreeing not to try to keep emissions to a level that would not that would allow us to keep global average temperature below 2 degrees Celsius increase. Increase compared to what? Compared to the global average temperature we had in the pre-industrial era. This number was refined in 2018. A new IPCC report came out. IPCC, I'm sure we all know, is the Intergovernmental Panel on Climate Change. And this new report said that in order to be able to continue living the way we are used to and support social welfare, we need to try to keep emissions to a point that the global average temperature will not increase more than 1.5 degrees Celsius compared to pre-industrial era. Are we performing well with regards to this global commitment? Well, as I say on my slides, the 1.5 degrees Celsius goal is slipping away fast. However, we still have a shot. And in order to achieve this target, we need rapid, immediate, and global action. And basically, we need to first peak emissions now, 2027, halve emissions by 2050, and reach net zero by 2050. half emissions by 2030 and reach net zero by 2050. And basically, this is what is also included as a legal commitment within the European Green Deal, but also many other regional policy and legal frameworks. So the question is, can we do this? Is it possible to halve emissions by 2030 and become net zero by 2050? Well, I lead something called the Global Climate Hub of the Sustainable Development Solutions Network. The Sustainable Development Solutions Network is the biggest network in the world of research and university institutions working on the implementation of the Sustainable Development Goals. One of these goals is SDG 13, is about climate change and climate action. But one should be aware of the fact that these Sustainable Development Goals is a holistic framework, and each of the 17 goals affects each of the other 16 goals. It's very integrated. So when one is trying to achieve climate neutrality, at the same time needs to achieve many other aspects of all the other 16 goals. Now, this Global Climate Hub came into existence after Jeff Sachs and I. Jeff Sachs is Professor Jeff Sachs at Columbia University, who is leading SDSN globally, and I'm leading SDSN in Europe. So we've traveled around the world, not just Europe, but around the world, and tried to identify what would accelerate the transition to 2030 and 2050 in order to achieve exactly what I stated there, halving emissions by 2030 and reaching net zero by 2050. And what we've understood from governments, from regional, national, subnational authorities, even local authorities, even institutional leaderships and company discussions. So we've talked to different stakeholders, including politicians, policymakers, financiers, businesses, civil society, of course, scientists, and of course, technology developers. We've concluded that what is needed is a detailed plan, a quantified, detailed plan, not verbal descriptions, but a detailed plan of transition and transformation from today to 2030 and 2050. And this plan has to be costed, and also the financing for its implementation should be made explicit. The blend of the financing and the sources of the financing. So at the moment, we are working in the countries that you see colored on this map. We are not working in the areas that are gray. All other areas we are working. And the structure in which we are working is very interdisciplinary, but also puts together all the relevant sectors that are important in being transformed in order to achieve the 2030 and the 2050 goals. So we have explicit modeling for downscaling climate scenario. All these are mathematical modeling. We have explicit modeling of the energy sector, the transport sector, the land use sector, including agriculture and forestry, the marine use sector, including shipping and energy production from the sea, and fisheries and aquaculture, the health sector, the innovation sector. Each of these models is simulated, but not on its own. It is interactively simulated between all the different sectors. So we have a really integrated intersector application and simulation that allow us to identify the transformations that need to happen in each and every year at each and every location. So it's dynamic over time and space and between sectors. And at the same time, when we have the simulated results, we embed them in a general equilibrium analysis model, which allows you to see the effects, the economic, the monetized effects of each and every sector in terms of the transformation that it needs to do, and not only within a country, but also trade effects as well. So at the end of the day, we know how much the transformation costs and also the effects of this transformation on different sectors of the economy, on different income groups, and also on trade. And it is important to have this integrated intersector modeling. Why? Because when you talk to the Ministry of Energy, and then you talk to the Ministry of Agriculture, and then you talk to the Ministry of Climate Change and Civil Protection, and then you talk to the Transport Ministry, and then to the Finance Ministry, you need to be consistent with regards to what you're telling them. You need to be aware of the fact that changes in the transport sector will affect the energy sector and will also affect the shipping sector, and will also affect other sectors as well. So it is important to be consistent. And sometimes we scientists fail to be consistent because each one of us goes with their own model, specific on some sector of some issue, not integrating enough, and we drive them crazy because something more holistic is needed to actually go and implement transformations that affects the lives of people. Now, this is the first layer. This layer works with our stakeholder transdisciplinary engagement, which is basically bringing around the same table all the relevant stakeholders, all the different representatives that I've mentioned before, representatives from the financial sector, the ministries, the policy making people, the politicians, the scientists, the technology developers, the civil society, and asking them to comment on each step of our analytical, mathematical processes. Comment, integrate their views, their understanding, their vision, their fears, their preferences. And of course, this is done in continuing upskilling and reskilling efforts, because in order to engage stakeholders in such difficult and novel structures of processing, but also novel technologies and novel ideas of transformation, you really need to engage in upskilling, reskilling, knowledge, capacity building. And all this is quite novel. Bringing all of this together is quite novel, and it got attention from the best scientific outlets. And all of this is also documented in an AI-ready e-platform that brings together all the data we collect per scale, per country, per region. It brings together and makes available open access all the models for the different sectors and their integration. And it also makes available all the tools that can be used by the stakeholders to further investigate the dynamic and spatial transition pathways we recommend. Digital twins, decision support tools, visualization dashboard. And this will be open to the research community and the stakeholders implementation community, so that it is endorsed and used and enriched, not just with the results of the Global Climate Hub that now employs hundreds of researchers, but also from anybody who is really looking into scientific recommendations about the transition. The transition is not easy, it's complex, it's difficult, it's expensive. It definitely needs guidance from science. And that's why we have invested so much time and effort. And we are making all of our work freely available. And we are making all of our capacity building freely available. During the latest UN conference in Seville on sustainable financing, we presented the pathways from Europe. I will go fast now because these are results. I am just setting the scene here to understand what do we need to do in terms of compacting and facing and hedging against climate change. We need to halve emissions by 2030. We need to become net zero by 2050. And I also showcase a framework that allows you detailed recommendations on how you do that. And this is what is included in these reports. So in this report, we have 35 countries, Europe, the Balkans, and the UK. But we are currently also working in Southeast Asia, in China, and Sub-Saharan Africa, and we are constantly increasing our outreach. So basically, we bring together low emissions analysis of the energy consumption and energy production. We are bringing together food and land use systems, emissions analysis. We are bringing together water requirements. We are bringing together land use requirements. We are bringing together marine use, emissions there of the marine sector, and how we can halve by 2030 and net zero by 2050. And all these models are running together. And we are running this model under different scenarios, the business as usual, and the scenario in which the national energy and climate plans and the nationally determined contributions are implemented. The common agriculture policies are implemented, and the water framework policies are implemented. And for each and every country, we provide a detailed plan of how to transform and achieve the goals. We assess the readiness of each country. We assess whether a country's plans are data-driven or descriptive. We assess whether a country is more focused on supply management versus demand management. We assess the planning horizon, the regional and national analysis. So at the end of the day, and I'm gonna very quickly close, we are able to make projections that showcase what we need to happen in order to achieve our goals. Energy consumption needs to drop by 25%, and we show how it will be dropped. Energy supply should increase by 30%, and we show how it should be increased, from which energy sources, so that emissions are reduced to half by 2030 and become net zero by 2050, and how the energy mix will transform away from fossil fuels. So very quickly, we have 19 countries out of the 35 following a balanced approach, working on both on demand of energy and supply of energy. 10 are more energy-oriented, working on efficiency of consumption. 6 are more supply-focused, working on alternative fuels and technological developments. But the net zero scenario, which represents the national commitments of these countries by 2050, gives the renewable supply, supplying the bulk of electricity and displacing gas and oil. Solar and biomass enter the end-use mix. Hydrogen generation ramps up alongside the new synthetic fuel module. Oil refining shrinks. Electricity becomes the primary carrier for residential services and industry. Imports of fossil feedstock vanish, reducing supply-side emissions. France becomes Europe's hydrogen hub. Spain and Portugal join as exporters. Germany still imports hydrogen. And not only we give very detailed description of the solution pathways for each and every country, but we also construct the green corridors, the efficient mixture of imports and exports of energy between countries in Europe, but also the Balkans and the UK. And I just want to remind you that we do that not just for the energy sector, but all the sectors are included in these results. For example, here I have the land use sector and how it changes under the 2050 net zero. Cropland shrinks, forests expand, pasture land declines, urban footprint stays stable. So to cut a long story short, the detailed pathways are developed and spelled out in a lot of detail, and then comes in the financial aspect of the whole thing, the correct valuation of all the different sources of energy and all the different impacts that the energy transition and the climate neutrality and the climate resilience transition brings. And it takes a lot of externality valuation, and then working in general equilibrium analysis to identify the optimal financing of these pathways, and at the same time identify not just financing the transformation, but caring for the vulnerable as well. So a package of measures for all those income groups or groups of society that are facing mitigating regressive effects. for the developed world and the developing world. And of course, the issue in the developing world is more difficult because it doesn't have the fiscal space and maybe sometimes not the private sector investment interest. So we do a lot of work on restructuring global financial architecture in order to find optimal funding streams for all of that. And we try to articulate the best timing of the implementation of the different commitments, policies, laws, and regulations in order to achieve in each and every country lower emissions, faster achievement of targets, lower costs, and lower dependency on imports. This is done by a tool that we developed using fuzzy logic, and it's really very revealing how much better than the national commitments we can do if we optimize the timing of the implementation of the different structures. And finally, we also provide a catalog of sources and instruments of funding that is very easy to use and I think very practical. So this is in a nutshell what we try to do. It's very exciting, but I hope it will attract the attention that it deserves as far as I am concerned, because it facilitates true transformation and implementation with some robust scientific guidance. This is just one element where scientists can help in the climate transition. There are many other aspects that are crucial in this climate transition. And I would like to continue with Professor IOANNIDIS, professor at the Athens University, ex-president for 10 years of the Athena Information Technology Research Center, and current president of ACM, the Association of Computing Machinery, who is a partner in this Global Climate Hub, developing all electronic platforms and applications that I have referred to. So Yannis, the floor is yours.
Thank you, Phoebe, for the introduction. Let me share my screen. Thank you for this. I'm the digital guy, so I will only talk about digital parts. United Nations Sustainable Development Goals, we all know them. 169 maybe changing targets. 70% of them are digitally dependent. They cannot be achieved without the technology that people, my community brings in, for climate or for any other. And if you look at the climate action and the targets that we have there, again, most of them need digital technologies to be achieved. The same thing is for the SDG indicators. What data is available is a key question. And as you see, the color, it's a little bit older, but still the green is much less than half of, yes, we do have available data, and where there are many reds, and the same thing is for climate action. So this effort needs people like me, like people in the community. And the key thing in all this is data and AI, because AI without data doesn't mean anything. And just to show you, this is a typical data science, artificial intelligence pipeline. We start from domain data, be it climate or economic, socioeconomic, and so on. Then we do a lot of data engineering before we reach to the, everyone talks about artificial intelligence, but until machine learning and artificial intelligence elements can happen, okay, a lot of data stuff needs to be done. So data and AI go together. All this is done offline, and then eventually we have data visualization, Phoebe mentioned it, and other modeling. And there are different types of people. The thing is global efforts. Well, global also in the sense of the different disciplines that you have bringing in. I am a data guy. For example, you need artificial intelligence people, and you need the domain scientists or the policymakers and so on to come together. And when it comes to data, you need data to be openly findable, accessible, interoperable, and renewable, and to have quality data. FAIR is a term that is being used because it's a very cute acronym, and it's unfortunate that it cannot find another cute acronym where openness is important and quality is important. And I want to emphasize openness. The world has been tearing down walls for, I don't know, between 1990 and 2010. And for the past 10, 15 years, the world is building walls again. Data sovereignty and privacy and local centers are prominent. And in order to achieve this, we don't need walls. We have to be open in order for all the data to be used and AI to be fed with appropriate data to achieve our goals. This picture of the platform that is being built by my team as part of the Global Climate Hub of the SDSN. Phoebe mentioned this. I won't go into the details of all the models and all the types of things, but again, it all begins with data. Lots of kinds of data, heterogeneous, multimodal, and they need to come together. Deep technology from computing needs to enter into the picture, always in collaboration, always based on the needs of the domain scientists. And a bunch of data-centric efforts, I won't go into them. Again, digital twins, AI tools, data is key. And for example, not just even to deal with the actual climate issues, but also how to make awareness of people around it. Still, again, data technology, AI technology, and other computing technologies like virtual reality can bring people into a set, like in this particular example from an effort called Arsinoe, to have choice experiments and ask people, how much are you willing to do this or that, or not do this and not do that? And this will be very affecting on what kind of environment people will read. So lots of work that can be done to sensitize the world. And it's not always good if you have AI and data science and so on. Yes, if we can achieve the goal is to achieve the SDGs and get to a better world, but also this technology imposes on the climate. It consumes energy, it consumes resources, and it may work on the other direction. So we need balance. And in terms of global, let me say, Phoebe mentioned, I'm the president of the Association for Computing Machinery. It's the largest organization of computing professionals. Digital and computing is our target, but we care about technology policy, we care about policy and the world's problems. And as an example, in the recent the United Nations Financing for Development Conference, ACM was an accredited organization, and it established a side event, Smart Technology Fair Finance, the Promise and Risks of AI for Development. It was moderated by a professor of AI responsibility, Virginia Dignum in University of Umeå in Sweden. And it was a virtual event. These are the panelists. You can see Phoebe next to me as familiar faces from this participating. The top line and myself were computing people. Phoebe and Michael on the left were economists, and the two lower lines are politicians. We all have to come together at the global level to solve the issues, otherwise we cannot. Thank you very much.
Thank you very much, Yannis. Obviously, the data and digital component is crucial, not just for saving what we need, and not just for making usable what we develop, but also for deploying what we develop to the stakeholders that need to implement it. Our next speaker is Ketan PATEL, Executive Director and Trustee of WAAS and Chair of Force for Good, CEO and co-founder of Greater Pacific Capital. Force for Good was established in support of the UN Secretary General Roadmap for Sustainable Development. Ketan will explain it in more clear terms, but the idea is to engage leading global financial institutions and technological companies in the roadmap and its implementation for sustainable development. Ketan, the floor is yours. The question I wanted to ask is where you see the challenges and what practical step do you think we can take in order to engage public and also other stakeholders, financiers, financial institutions, private institutions in the roadmap to net zero.
Thank you, Phoebe. You know, and I'm wondering what I can tell the audience that is going to make a difference in that short amount of time. So I think that the challenge is that we cannot address climate change or any other major issue in the world because of how we've chosen to build our society, which seemed logical coming out of the industrial age. But at this stage, it doesn't work. So we built our society on mass consumption, which implies that we end up consuming everything else that we possibly can and exploit every resource, every planetary resource and every human resource that we possibly can. So that might have been sustainable with the early days of the industrial era, but it cannot be sustainable with 10 billion people by 2050. We don't account for the implications of doing that very well in financial statements. So we believe we are profitable at doing this. But if we fully accounted for the damage, we would not be. And then we use technology, in particular, social sciences technologies of various types, to spread the word that actually the problem is climate change or some other factor, but not how we built our society. And as a result, the consensus you would hope amongst the population that climate change should be the #1 issue has been falling apart, not only in the US, but also in Canada, in the UK, in Europe. In all these places, climate change has fallen in the priority list of what concerns people. If we wanted to fund it, we could, and we could do it very profitably because we're in a technology, information and science age that is making massive breakthroughs. And those breakthroughs could be spread all over the world profitably. And it is expensive, as you said, Phoebe, but it's something that can be done profitably if we choose to. But if you wanted to stop yourself doing it, what would you do? #1, you would launch an economic conflict on trade and tariffs across the world. #2, you would dismantle everything that matters in terms of multilateralism, so the ability to work together. #3, you would have wars that scare everybody so much they have to invest in more and more arms and security. As a percentage of their GDP, of course, that is rising, and therefore you could not afford to do anything else. And that's what we're doing. We are almost consciously stopping ourselves from solving this issue, climate change, and every other major issue. So it is no surprise that we are inexorably heading towards burning the planet and not being able to solve it. What are the solutions? I think there are many solutions, but the first is that you need enlightened leaders, which seems scarce, but we do. So #1, you have to have economic advancement and development. And if you do, people do not have a rational reason to vote for people who pretend to deliver that. #2, you do need early warning signals and technologies. #3, we have to roll out clean energies at mass and scale across the world. #4, we need a world investment plan that shows it's profitable to address the major issues. And #5, we have to take back control of the truth and scaling communications to do so. These are all challenges that we can rise to. But for now, we've constructed a world that makes these things nearly impossible to do. I'll stop there and hand it back to you, Phoebe.
Okay, thank you very much, Ketan, for identifying a list of high priority solutions. Our next speaker is also doing that. He's focusing on one of the major drivers for these solutions pathways of both greenhouse gas emissions and biodiversity loss, and that is material consumption. So Andres WIJKMAN is a former co-president of the Club of Rome, a board member of the Swedish Development Authority, and he will be introducing some of the results of the most recent report of GRO. Andres, the floor is yours.
Thank you very much. But let me begin by saying that I agree very much with the chair that climate change, and by the way, also with Ketan Patel, that the climate change is but one of the many challenges. Even if we would be able to solve climate change and mitigate emissions, we would still have to address the relationship between the economies, the populations on the one hand, and natural systems. And we fail so far to live in a way that we don't destroy what I would call the life supporting systems. We have an economic model that focuses on production growth, which is a qualitative measure or objective, and has nothing to do with quality. It can be good, but it can also be uneconomic or bad. So we need new indicators. I was planning to show that material consumption is the main driver. While I agree that the phase out of fossil fuels is immensely important, and the focus on the energy system is very important, electrification, etc., but unless we understand that materials are the main drivers, we will not succeed. And in the most recent report from the Global International Resource Panel, the Global Resources Outlook 2024, we could show that this type of extractive economy, extraction of materials and processing materials, generate almost 60% of the greenhouse gas emissions. And here we talk about materials like concrete, steel, ammonia, aluminum, plastics, textiles, electronics, and biomass. And to change that, we need to use materials in a much more intelligent and effective way. Material use have gone up between 2 and 3% year by year. And there is a direct correlation between conventional economic growth and material use. And if this continues, we can forget about climate change. We can forget about biodiversity loss. We will lose the game. So that's really an important message. And while I was very interested, Madam Chair, in all the strategies that you showed us and all the modeling, I couldn't really figure out where materials and material consumption fits in. It has to fit in, absolutely. We have come to the conclusion that you can use materials much more efficient. You can move away from the linear production model, where most materials are only used once, to a more circular model. And you can also do away with a lot of the waste in the system. And if we focus on the 4 most important systems with regard to energy and material use, construction, mobility and transport, energy and food, in each of these sectors, we have shown that you can do things, you can do more with less. But we have to go one step further, because that is not enough. We have also to start a discussion on quality of life. What is the most important thing in life? It's not to buy more stuff. It's really so many other things. And here we need other indicators that focus on quality and that paves the way for a model of the economy which focuses where the objective is sufficiency. And here again, the top of the income ladder, the 1 or 2% at the top, they consume enormously. 20% of greenhouse gas emissions are directly generated by the 1% on the top. So here we have to do something, and we need policy measures to do it. So I stopped there in the interest of time. I hope I've conveyed a message that material consumption is a major driver, and we have to start looking at it. And of course, it has to do with the conventional economic model, which only values production growth and which equalizes production growth with welfare, which is flawed, which is wrong. So conventional economists have to be brought in and provide us with a much better model. Thank you.
Thank you very much. Indeed, the transition from the linear to the circular economic model and the beyond GDP model are a big part of the picture, and if I may say, are a big part of the systems modeling that I showed in the beginning. Thank you very much for very insightful comments. Our next speaker is Massamba THIOYE, Project Executive of UNFCCC Global Innovation Hub at the UN Climate Change Secretariat. Massamba, what is needed to refocus innovation and climate action and make them better serve these climate goals of halving emissions by 2030 and achieving net zero by 2050?
Thank you, Phoebe. I think to jump directly at the heart of my presentation, what needs to be done is the inner development of the many people for the right outer action and system change. For the inner development of people, we need to take any opportunity to work together so that we can appreciate the contribution of others, build the trust, develop self-awareness and awareness of others. It is also important for the leaders to create space where at scale, individual citizens can have positive interaction that can lead to positive emotions. Positive emotions are very important for inner development. We need also to give to the many people opportunities to contribute to meaningful and purposeful activities. It should be considered as a right, not a duty. Each individual citizen should be given the right to contribute and to contribute to something that is meaningful and purposeful. This serves inner development. Now, for the outer action, we need to be holistic, and I fully agree with the intervention just before me. We cannot address the challenge of climate change, biodiversity loss, land degradation, and use of natural resources beyond planetary boundary in isolation. This is an intertwined crisis, and yes, it's a challenge to try to address them holistically, but we do not have the choice. We need to work on all these things in an integrated manner. Just to give an example, you will not address climate change unless you recognize the agency to non-human living. We need to collaborate, radically collaborate with non-human living so that together we join force and address the challenge of climate change. So it means that we need to have a society where we are not just extracting ecological value, but we are also producing ecological value. We need to give to the many people, but also to non-human living, opportunity to contribute to and benefit from the creation of ecological value. And we need to prioritize the most transformative climate and sustainability action. This is really important. We put our effort on trying to improve in a not really impactful manner what we have currently. And most of the time, this is not the best approach. We need to try as much as possible first to reduce consumption, and then where it is not possible, to disrupt products that have very high negative externality and do not fit into the future that we would like to build. And finally, we need also to enhance circularity of our economy. These three types of climate and sustainability action are the most transformative one, but yet they are not the one that most of the climate strategy are focusing on. Just to give an example, we are talking a lot about shifting from combustion car to electric vehicle. This is good, but we need to ask the question first, why do we need car at the first place? So we need car for mobility. Then can we use innovation to satisfy the need for mobility with less car? So for example, can we use GIS, GPS, remote sensing, and try to build 15-minute city where most of the product and services are available at biking or walking distance. And by doing so, you disrupt motorized transportation. This is much more transformative than shifting from combustion car to electric vehicle, although it's needed. For the system change, to conclude, we need to reinvent the world with a new systemic innovation framework that is life-centric, vision-driven. It's not about only solving the problem. We should not use innovation only to solve current problem. We need also to use innovation to establish the future that we would like to build, to paint a future and use innovation to get there. It has to be need-based, not just working on, let's say, the value chain that are just means, but also working on how do we satisfy the needs differently. It has to be collaborative among nations, within nations, with multi-level climate action, and as I have mentioned, between human and non-human, and it has to be transformative. Finally, we need to reinvent also ourselves with a new metacognitive reframing approach that challenge the way we think, the way we act, and the way we interact, and promote three key values that are really important for a net zero transition: caring, sharing, and daring. I will stop there.
Thank you very much, Massamba. Indeed, the behavioral change is one crucial aspect, and indeed is one aspect that takes a big amount of time. Because part of my work is on behavioral economics, and there is a big literature that it is really one very important, crucial transformation step, but also one that takes time and education and knowledge. But I would like to, I see Andres' hand, so I would like to give you the floor. Did you?
Thank you. Yeah, thank you. I cut my intervention too much. I should, of course, have made very clear that we are absolutely clear about one thing: the enormous difference, both in standard of living and also in material footprints, between high-income countries and low-income countries. I mean, I live in Sweden. My footprint is probably 20 tons per year in capita. The equivalent footprint in a low-income country, somewhere in Africa, maybe is 3 tons. And of course, to enhance standard of living in low-income countries, you need more materials. So you need to increase the footprints. And we have to lower our footprints step by step, by being more efficient, by being more intelligent, by doing away with waste, and by moving towards efficiency. So this is very, very important. Without that, there's no way we can achieve what we want. Second comment is, of course, that we are stuck in an economic model that has been brought to us by neoclassical economists, and they started already in the end of the 19th century. And at that time, nature was enormously big, abundant. Natural resources was not a problem. Financial capital, technology, innovation was scarce. So then they focused on that. But to continue to focus on that and neglect nature and natural resources that are outside the model today is, of course, idiotic. And that conventional economists have not left this nature blindness behind them, I think is a mystery to me. And let me end by quoting Gregory Bateson, who said many years ago, the major problems in the world are the result of the difference between how people think and how nature works. So we have to rethink the economic modeling, otherwise this is not going to work. Yeah. Unfortunately, conventional economists are not very active in this debate. And at the same time, they are in key positions everywhere.
Yeah. As an economist, let me just say, in our defense, that I lead the World Association of Environmental and Natural Resource Economies that now are numbered in the thousands. So, and we have a World Association, but also a European, a US Association, a Latin American, an African Association, an Asian, an Ocean Pacific Association. So nowadays, environmental and natural resource economists, the economists that study the interaction between the natural capital and structures and processes and the socioeconomic capital and structure and processes are a leading field in economics, possibly not the biggest. We still need to expand, but one of the leading fields in economics that actually gain a couple of Nobels. So in that respect, we are doing something to that. And because I have to close the session, it's 5, I will just say that it was an amazing structure that we had here with opinions from different sectors, thought sectors, I would call them. So thank you very much. Bye-bye.